Hi everyone. In the given problem statement, we have to implement binary search tree iterator. So let us take the example of this binary tree 7, 3, 15, 9, and then 20. So here, right, it has been clearly written we have to do an in order traversal. So if I do in order, so in order is basically meaning first left child is going to be done, then root node, then the right child. So if I store all these values while traversing, the value would be 3, then the right child, then the value of 9 is going to get added, then 15, and at last 20 is going to get added. Now it's been told that first you have to implement, and let's say we have saved that in a stack or a DQ. Now, let's say if I am going to search for the next operation, so I have to pop the last element out. So here, right, when I'm getting a next operation, so I'm going to pop 3 and return 3. Similarly, if I get another, I can keep on popping it out until it is going to check, right, has next. So if there are elements present in this stack, then we are going to return true, return true. In case the stack is empty, we are going to return false. Pretty straightforward problem. Only thing is that we have to implement it in form of a class function. So that could be a little bit complicated, but otherwise just iterate through that entire tree in order traversal and save the values in a stack or a DQ, and then keep on popping the element whenever it is searching for the next one. And in case it search for has next, then check whether the stack is empty or not. Let us jump to the Python solution. So the first thing is that we're going to initialize our root. So self dot root equal to the root of the tree. Now we are also going to define our stack. So self dot stack. We can also use a DQ, but for the use of simplicity, we can use stack. Now if I, or let's say let us use DQ, it would be more interesting. COLLEC collections dot DQ. Now we are going to do our DFS. So DFS, we are going to pass in the root. Now in case not root, then we are going to just return the value. So return, else we are going to do DFS. So it's an in order traversal. So first we're going to do for the root dot left, then our self dot stack dot append our root dot val dfs root dot right, and then dfs of self dot root, and that's it. I think our code is going to work and we are going to get the in order traversal added into our DQ. Yeah, one thing I forgot to do, we have to import the collection package. So import collections to give the DQ. Now we are going to check has next. So return self dot pop left from the stack. So it would be self dot stack dot pop left, and now here I'm going to check whether it is a value. So if length of self dot stack is greater than 0, we are going to return true. In all the other cases, we are going to return false. So let me write it down, and now let me run the function or run the code. I hope it works, unless there are some spelling errors. So you're able to see, right, it worked perfectly fine. Let me submit the code, And here, right, if you look into the time complexity is going to be bigger of n because you're traversing the entire uh, all the elements in the tree one time, so it's bigger of n. But obviously time complexity will be more because you're using a stack function to store the elements. So that's all for this video. See you in the next one.